Well, this is a modification of a portable and collapsible paint spray and fume hood that I saw on a really decent YouTube video. This fellow had a box that was collapsible, and he'd hooked it up to a box fan with a filter on the back end, and he was able to paint in his garage and absorb most of the paint overspray into the box, into the filters. But paint spray is only one component of painting and spraying, and the other component is the fumes and the solvents that are in the air with the paint spray. So this is simply an updated sort of a modification of his original design, and I've modified it to actually be more of a fume hood as well as a paint spray booth. It's constructed of 1/4-inch plywood. The hinges are made out of duct tape, 3 layers, and I've used a very wide 4-inch duct tape for most of the hinges. The sides and the top are held together with strips of Velcro, the black material, attached to both sides, and you simply attach it like that, and it holds so strong that it's difficult to get it apart. So the box is fairly stable. I have a fan apparatus on top and a metal tube that goes out of the fan, and it exhausts the solvents and the paint spray out of a window, in this case from a closed patio. The fan is a 70 cubic foot per minute bathroom fan, and it's hooked to a 4-inch metal dryer pipe that goes through an elbow and then out the window. The other videos I've seen use that corrugated plastic dryer tubes, but they create vortexes, and if you have bends or kinks, elbows near the fan, it cuts down on the speed. There's a couple other video clips along the way on this fan build, but it's a box that sits on top of the fume hood. And if you see the airflow arrows, there are 2 small air conditioner air vent filters in series that pick up the paint fumes, and then it goes through the bathroom fan and out the window through the pipe. And the fan has an on-off switch on the side of it, but that is connected to a dimmer switch, so I can vary the fan speed and the air output. The box itself is approximately 14 square feet or cubic feet inside. The fan is rated at 70 cubic foot per minute, so that I've calculated that the air volume of the box is changed every 4.5 minutes. So, or it's changed four times per minute, sorry for the calculation. So these are a series of video clips. I'll take it apart, and I have a build of the fan that I'll attach to this. And if anyone has any interest in it, it's simply a modification of a really novel idea that I saw on YouTube. Well, the real advantage of a foldable or collapsible spray hood is that you could fold it up and put it out of sight or out of the way and use the space for something else. And in my case, with very limited space, it's a really great idea. The spray hood that he had worked on was simply to catch the overspray. And again, I'm more concerned about the overspray and the fumes from lacquer and enamels. So this is what it looks like when it's all folded up. The sides and the bottom all are folded up with the duct tape as hinges. The strips of Velcro come off, and they're very secure when the box is put together. and the door and the pegboard sort of line up. The tube and the fan box can be stored someplace else rather than behind a door. I do have a couple of video clips building the fan box and the filter box. This is what it looks like when it's completed. And it has two small air conditioner filters below the fan motor. I am looking at a Dayton squirrel cage with the motor that's outside of the airflow. There is kind of a concern of explosions if you have a motor that's inside of a fume environment. This is simply a prototype. I'm going to probably change that if I use it more. The filters simply slide into a rack, and this door closes and seals it off. I put a small electric box on the side that's connected to the wires from the blower motor, and a bracket to wind the power cord around when I'm not using it. And of course the tubes, the exhaust tubes, can be put someplace out of sight as well and hung up. As far as plans, I drew them up based on what space I had. And my height was 40 inches maximal. The bench is 23 inches deep. And I wanted it as wide as possible so that I could put in a couple of pieces of just paint or to hang. I chose 32 inches because that would fit behind a door and when it's out of sight. So essentially the plan diagram is for 5 pieces of 1/4 inch plywood, as well as the flaps with the Velcro. My dimensions are 35 inches tall, 32 inches wide, 23 inches deep. A side view is a box with the fan and filters on the top. I have the exhaust blowing out the front, but if someone had a garage or a different space, you might blow the exhaust fumes out the side or the back and out the building. I did rough calculations and came up with a box volume of approximately 14.9 cubic feet. The blower fan is rated at 70 cubic feet per minute. So I come up with about 4.6, maybe 4.5 changes of air per minute at maximal. The fan is probably rated at a no-load speed, and my box, I'm sure, has air leaks. But when I do the little test, I can hold a piece of paper against the pegboard in front of it with the fan running, so I believe I've got enough air volume to exhaust the fumes and the paint spray out the window and not allow them to go into the building. And again, I put the link for this spray hood in the box below if anyone's interested. He certainly did a better job than I did. I simply modified it to have filters and exhaust any fumes. Well, this is another video clip of the fume and spray hood that exhausts paints and solvent material outside. Again, the box is constructed of 1/4 inch plywood with duct tape for the hinges, flexible hinges. It all comes apart and folds into a compact compartment that I can store someplace. I don't really have a lot of space, but when I do paint, I don't want to have fumes all over the patio and going into the building. So the flaps that hold the bottom and the top to the sides are done with Velcro, very stable material. In addition, I've put on little D-rings for picture frames and small bungee cords hooked to D-rings on the front door and the lower panel. What I have here is a piece of pegboard on the bottom that has a series of holes, and the airflow goes through the bottom, up through the box, and out the fan into the window. I tried a couple of different variants of the door, but I came to just use a single panel. I had originally the door had a hinge in the center and it would fold up against the ceiling, but that was more trouble than it was worth. So this door simply is a single panel that's on top of the pegboard. So the air goes through the pegboard, up through the painted material, and out the window. And if I remove the door, This shows the interior of the paint spray booth. I frequently put stuff on a what's called a Lazy Susan from a dish cabinet dish container, and can rotate the material when it's being painted. And this is the bottom of the fan box. There are two 10 by 10 air conditioning filters that take the air out of the box and exhaust it through the fan out the window. This is just the right height. I can spray in there and then put the door back on, turn the fan up a little bit higher, and let the fumes exhaust out the window rather than drifting through the building. So this is it's probably the second little video clip. I'll put the door on again and show the airflow. It's enough to keep a piece of paper attached to this pegboard, and like I said, I think the air is going through here at maximum velocity about 4.5 times per minute. So it's a complete change of air 4 times a minute. And again, the door and the bottom panel are held on with mini bungee cords, and I've attached small pieces of bracket to the front of the panel, and that simply catches the side of the spray booth. That probably may show up down here. Okay, the next one will be the airflow. Well, in setting up this spray booth and a fume hood, I was a little concerned about the airflow and whether the box was airtight and whether it would in fact work. So I've used a dimmer switch that's hooked up from the electricity from the outlet to the blower motor on top of the box, and I'm able to adjust the airflow. And what I had thought about doing is running it at full speed for a while to clean out any dust or lint in the box, then turning the fan down a bit while I was spraying, then closing up the door on the box and exhausting the fumes out the window. We're in the middle of a rainy day, so I've closed the window and directed the vent straight down, and there's no paint in the booth, so we don't have to worry about fumes. And putting a piece of paper doesn't do anything, but turn on the blower, give it a second to start evacuation, and the paper is sucked into the pegboard, so that it's a decent airflow, and when you turn the fans off, the paper drops and can be removed. It no longer is supported. Again, it takes about 30 or 40 seconds to get the vacuum in the box enough to hold a piece of paper, but it's certainly enough to keep even a third of the paper with the vent is enough to hold up the whole sheet, and it simply falls away when the fan's off. So that was acceptable to me, plus when I put the paper on the end of the exhaust vent, you can tell that there's a decent amount of airflow. And again, I've used thin-walled, rigid aluminum piping. The vent, or the fan, has a 3-inch exhaust port, but I was able to find an adapter that goes from 3 inches to 4 inches, and 4 inches is the diameter for most dryer vents. And I've kept the vent as straight as possible until I have an elbow that's about 30 inches away from the fan, and then it goes into 2 elbows and just out the window. I think that if you have the elbow too close to the fan, you decrease the back pressure. It's like headers on a motor. You want the flow to be as uniform and as gradual as possible when you leave the source, the motor or the fan motor or the engine motor. So again, the volume is okay. And again, the fan is rated at 70 cubic feet per minute. I guess that's optimal conditions. And the box is about 17 cubic feet. So again, maximal calculation is about 4 to 4.5 times that the air is changed in the box every minute. And it's certainly enough to hold up the paper, and I assume it's enough to take the fumes from lacquer or an enamel spray paint and exhaust it to the outside. And that's after it's gone through 2 of the filters. Under the fan there are 2 air conditioner filters, and there's a video clip further on that shows building the box and how the filters are inserted below the fan. There's a little door that's removable, and you can replace the filters in a couple of seconds. Well, in order to make the collapsible or foldable paint spray booth into more of a fume hood, there's a couple of additional items I think are worth experimenting with and putting into the design. The first is the type of fan. Now the YouTube video used a box fan set up to a filter, and that was simply to collect the overspray. But that foldable paint spray booth allowed the vapors and the fumes to go right into the room and circulate in the air you're breathing. And I'd like to prevent that and vent the fumes outside, as well as make the box a bit more airtight. The first aspect is the fan. This is a Hampton Bay. It's rated at 70 cubic feet per minute. It would take the place of the box fan, except that the output is directed on a 3-inch outlet pipe. The other thing I think is worthwhile considering would be the speed of the fan. And I've picked up a tabletop dimmer switch. And this can be used to adjust the volume of the fan while you're preparing to paint, while you're painting, and then while you're reducing the fumes out of the spray box. Again, this has a 3-inch outlet. The box store has adapters of all sorts. This one goes from 3 inches to 4 inches. 4 inches is the common dryer pipe diameter. And my intention is to use straight rigid piping, if possible, rather than the corrugated or the tinfoil covered composed pipe. From what I've read, the collapsible or this rough surface creates vortexes and reduces actually the flow of air through the pipe. And this isn't much more weight, it would be more trouble to store, but I'm planning on using 24-inch lengths of this rigid pipe along with elbows and a adapter plate to direct the flow outside of the room into the outside air. Again, I don't know how significant this is, but from what I've read, the corrugated pipes create vortexes which reduce the airflow. 2 other things I think are worth considering with making a fume hood in addition to a paint spray booth, and that is this extra wide duct tape. I plan on making the hinges out of duct tape, not flat fabric that's been glued to the corners of the plywood sides and the bottom. And I think 2 layers of this plus a couple layers or a couple strips that are perpendicular to the opening might provide enough hinge mechanism as well as being airtight. And the last thing I think worth considering is that where the flaps attach the bottom or the top to the sides of the box, I plan on using these foam window strips. They're air sealant. And what it would do is simply cut down on the airflow or lost air or fume evaporation or leakage into the box from areas that you don't want air coming into. These are only a couple bucks a bag, and they're 17 feet long, so that should be more than enough. Okay, these are just some of the items, in addition to a lamp, but I don't know if that lamp will fit in this particular box. Well, this is kind of a crude design and fabrication of a filter system for the paint spray in the fume hood that I'm trying to make. And what I've represented here in the diagram is the area of the paint spray hood and the airflow going through two filters before it gets to the exhaust fan, and then going out the exhaust pipe out to a window. What I've created over here is a box that two filters can slide into, kind of what beekeepers have for their honeycombs. And the air goes through the first filter, and this is the removable lid that comes off. There's a wooden partition that is constructed from Home Depot 5-gallon paint sticks as a barrier, and as the air flows from right to left, it'll compress the filter into that stick, and the second filter will be compressed into this piece of plywood, and then the air moves into the exhaust fan rated at 70 cubic feet per minute, and then up and out of the exhaust pipe to clear into the window. I have to test this, but what I plan on doing is having the lid attached with weather stripping, and then in front having a panel, a masonite panel, with a hole to accommodate the filter. And I'd like to be able to move that. There'll be a hole in the paint spray fume hood on the top and on the side, and this panel with the exhaust fan will simply set on top or on the side, and perhaps screwed or bolted in depending on how extensive it gets. So there'll be two holes in the spray hood, and two of these panels. One panel will have the filter system, and the other panel will have a light, a round light equivalent, and the masonite panel will be about the same size. And it'll just be simply attached to the side or the top of the fume hood, depending on which orientation the fume hood is in, whether it's vertically or horizontally. So again, just a rough, crude diagram of the airflow going through two filters into the exhaust hood and then out an exhaust pipe. The filters have to slide in fairly easily, and but tight enough to compress each other with the airflow. This is the completed prototype for the filtration and the air blower vent system for the top surface of the folding spray hood fume hood apparatus. Again, I've wanted to place this on top of the spray or fume hood, have two filters, a blower motor, and then an exhaust port that heads out of a window. I'm using a workbench that gives me about 40 or 42 inches of height, and I'd like to use a straight aluminum pipe that heads right out the window. If you have bends or you use the corrugated or flexible type of dryer hosing, it creates vortexes and the elbows can reduce the flow, so I'm hoping I can get by with a smaller fan. This, by the way, is a 70 cubic foot per minute bathroom fan. I understand that it's not explosion proof, and I am more interested in looking at flow rates at this point. I know that Grainger sells a series of Dayton blower vents that have the motor outside of the squirrel cage, which would be essentially explosion proof, but I'm just using this to start with because this was $30 and it was cheap. This gray apparatus is primed and sealed, and what it's going to do is to fit on top of the spray hood, fume hood. And if you can make out the arrows, the airflow goes from the bottom to the top, goes through the blower, and then out through the exhaust port through the window. I don't have a fancy camera system, so I'm going to turn this off for a second and take it apart and show the individual components in case someone wants to build something similar to this.